part 2. Let's start adapting this to a particle system. Okay, so this is a new file completely. I will remove the cube, add a sphere. Okay, now we will create a plane, and I will make this plane, I will add a constraint to this plane to make it face the camera. So we will track 2. This is what axis we want to face the camera. In our case is the positive Z, sorry. This one, and we have to target the camera. Okay, this way the front is facing the camera. If we leave it like this, the UV will be inverted. So have that in mind. Okay. Now I will give it just a starting size that I like, around there. Control apply scale. What I want to do here also is to parent this plane to the emitter. That will be our sphere, because if we move the emitter, the particles that are here will be facing the same as this plane, and that doesn't point at the camera. So I will parent this, Control P, select the plane, select then Shift select the sphere, Control P, object. Now if I move this, the plane will always face the camera, and the particles you will see now. Okay, so now particle system, new particle system. Selecting the sphere there, I will set this to a lower number, 200. Go to render, change this to object, and the scale I can set it to 1. This is the size of that we set. We will use the plane, set object rotation here, so they all face the same as the object we created. Okay, now we can change this. Just for this animation, I will change the field weights gravity to 0. And okay. The lifetime 50, it's fine. Okay, now let's go to shading. You select the plane here, not the sphere, and you add a new material. Let's call this sprite. Not sure if that's the way you pronounce it, but you will understand. And now I will show you the particle info node. So nothing works here because we are using Eevee. Okay, this doesn't work with Eevee, and this works for cycles, of course, but if you want to use Eevee, we will find a workaround at the end. Now let's set this to cycles and see what happens. Okay, so now in cycles, what we can do is a simple, it's almost the same we did with the timeline. Instead of the total frames and the frame we are on, we will do it for each of the particles. We will be using lifetime, that's the time they have until they disappear, and divide. And we will use the age of the particle. So this will give us like a 0 to 1 number from birth to the time they die. As you can see, when they born, they are at black 0, and the moment before they disappear are at 1. Okay, this is what we will be using to drive the animation. Let's Ctrl J and rename this to timeline. At this point, I will be going a bit more complex because I will be using this image, that's a 3x3 sprite, to make it more flexible, because this way we are not tied to a, like if you want, I don't know, 20 frames, you don't need to make like an image that is 1x20, and you can create the animation in multiple rows. So I will be explaining how to do that. Anyway, the setup will be available to download also. If this is a bit too complex for you, you can skip it and just download the file. But I want to explain how it works, and also for the ones who want to learn, you can follow along. We will start with the same we did on the other setup. We need the value our x, y, in this case is 3x3. We need our UV map. Okay. And we will start by dividing this map. Divide. We need a combine here. Our x, our y, and we will be dividing this. And now texture, image texture. To make it easier, I created this with numbers. And since the UV grows from bottom to top and from left to right, that's the orientation of the numbers I'm using. Okay, so we have this. We are placed on the first frame. So the difference now is that we need to, every 3 frames, we have to jump on X, we have to jump again to the first one. So we will use a modulo there. And for the Y, we have to only move every 3 numbers. So 1, 2, 3, then it moves up. 4, 5, 6, then it moves up. On the case on the X is 1, 2, 3, goes back to first one. 2, 3, goes back to first one. So that's what we are going to do at the moment. So things that we need. I want the number of total frames. So I use a math node, and I will use simple multiplication, x by y, and this is our number of frames, of total frames. We can rename it. And then to have the animation, we will use our value that grows from 0 to 1, and we will multiply the number of the timeline by the total of frames. Okay, so at this point, this output, it's a number that will grow from 0 to the total number of frames, that is 9. Okay, now we need to calculate what do we need for x and what do we need for y. So we will do like 2 different paths. For x, we need to make it change to from 1 to 2 to 3 and then go back to 0. So we need this to, so we need to use math modulo and we will make it go back every 3. So we'll use x again, every the amount of frames we have on the x row. Okay, so that's 3 again. Then use another math node set to snap, in increments of 1. So it will only change the value, the output, every 1 value increment. The fractions won't count. That way we don't have an animation of a 1 moving to the 2. We have it jumping from 1 to 2. And then we will use, at this point it's moving by 1 unit, and we need to move it 1/3 of a unit. Okay, so we divide this by the same number, by x. Okay, and then we will use another vector math. It's time to add and a combine. And this will be our x. This will make the x move as we wanted. It will go 1, 2, 3 and go back. At this point, since y is not a thing, we are not affecting the y, you will see how it goes from 1 to 3 and then it goes back to 1. As you can see there. Okay, now let's take care of y. In this case, we don't need a modulo because it doesn't go back to a number. It just moves every 3 steps or frames. So instead, we are going to divide this number that we have here by the number of y. And we will use again snap in increments of 1. We have this that goes from 1 to 0, so 0 to 1, multiplied by 9, 0 to 9, divided by 3, and then if we snap it, it will only change on each of those 3 steps that it has, and that's what we wanted. Then we divide the number by the y again, so we have how much we need to add to the y. And now we should have an animation that goes through every single frame. As you can see. And after a 9 disappears, because it's the particle lifetime, you can use mix shader, emission, or whatever you want. Transparency. Use this as a factor. That means white part will be the one on the bottom. We will use emission in this case, and transparency on the black part. And we plug this, and we have the numbers growing. We can change the emission color if you want to get rid of the shadow. Now you can create the sprites you want and make different animations. I think it's a cool effect for stylized animations, and I don't know, you can find a lot of use to it. Let's go to part 3, how we can drive this on Eevee that this is not working.